Hello. Normally I cover audio and video technology on this channel, but occasionally I do diverge into something else, and today is one of those, because I want to just mention a bit about installing this kind of lighting, which I'll put into a kitchen, and maybe if you want to do this, you can learn from some of my mistakes. So this is RGBW, so red, green, blue, and in this case warm white, but you can also get cool white, or you can get RGB only, or you can get RGB with cool white and warm white LEDs. So they have different amount of contacts on them. And in this case, they fit into this really nice diffuser strip, which supports it and can possibly give you some thermal management and gets rid of the strong coloured dots that you'd see from LED strips if you didn't have a diffuser. So these run at 24 volts, and that's a good thing because the higher the voltage, the lower the current for a given amount of wattage, and therefore the less voltage drop you get on the cables. These were supplied in 5-meter reels. Technically they're called 50-50, 60 LED per meter RGB warm white, 3000 Kelvin. So you can get different whites. These are IP65 rated, so they have a silicone gel covering on the top. 5-meter length at 24 volt. Now, of course, the 5-meter length is not likely to fit exactly what you want, and you can cut them to whatever length you require within certain limitations. There are cut points there. So every time you see the copper dots there, you can cut it and apply power there. So they're reasonably frequent. Of course, there are some distances you just can't get to, and there's a bit of a gap in the middle on this particular one. You might think, oh well, if I'm coming to the end of a strip I can cut it there and that'll be fine, and it won't. If you cut it there, these LEDs go out. I'll demonstrate that later. Now they are supplied with wires at one end, not in this one, it's been cut already, but unless you're extremely lucky, you're going to have to find yourself applying power to one of the cuts. And there are two basic ways of doing that. You can get some clips, some kind of connectors that connect to the end of there once you've cut this gel off, that will plug on, and they will have the wires that you need to connect up to. But personally, I'm not so keen on that idea. I think the trouble is when you're mounting these in the real world, you're going to finish up with situations where there's all kinds of angles going on, and there'll be pressure on those connectors and they're bound to come off. So far better to solder your own wires on here, and I'll show you how to do that. Here I have some of the RGBW wiring that I'm going to be using to solder on to the LED strip. So perhaps counterintuitively, the black wire here is positive 24 volts. Then you've got the red, green, blue and white. So each of those goes to ground in order to light the LED strip up. So now we need to solder those onto the LED strip. But as you can see, these are covered in this silicone gel. So the first thing I need to do is cut that off with a sharp blade. It should be said, this is all the sort of thing that's much easier to do here in my workshop with a microscope than it is when you're crawling around under a workbench in the kitchen. So it's probably worth setting up a comfortable place, perhaps with some sort of magnifier, to do the soldering work rather than trying to do this on location. The first thing I need to do is cut down through here. Now you'll be a bit careful. If you go too deep into here, you'll cut the tracks internally and ruin it. Okay, I've made a cut in the gel there, and I should now be able to take off the bit that covers the contacts. You're bound to finish up with some residue, and you need to go over that a few times to clear it all out. And this is where you want to finish up with the pads all completely clear of the sealant and a reasonable amount of material copper to solder onto. Now we can pre-tin those with a soldering iron. Let's do that. If you can get hold of tin lead solder, all the better. Now just to demonstrate it can be done, I'm using a soldering iron here. It's probably a bit on the big side. You know, you might like to use a smaller point on your soldering iron, but this is what we have right now, and it can be done even with this. Now if you do finish up with solder across these connections, it's not that hard to just sort of flick it off and try again. Now the wire similarly needs to be bared at the end and pre-tinned. You should finish up with something like that. Now we can pre-tin those. Now the pitch on these wires is just a little bit narrower than the pitch on the LED strip, so you might want to slightly tease out the two outermost wires slightly. Now we're in a position where we can solder those up. What I tend to do is, because there aren't enough hands to hold all the wires and solder at once, is to maybe just do some sort of tack soldering the first time round and then solder them better once they'll all stay in place. Okay, that's fairly well soldered. That's certainly not going to break off anytime soon. Now, if you want to be thorough, you can go over this with some heat shrink as well. Make sure, of course, that you don't cover the first LED when you're doing this. And the best way to heat shrink, actually, if you have one, is a hot air gun. This is, I think, 125 Celsius, so that's the set point for my hot air gun. Now that's a nice join, and we can test it. The LEDs will of course all work fine. Okay, I have the benefit of a 24 volt power supply in my workshop, but perhaps you could use a couple of 9 volt batteries would probably be a good start. I think 18 volts would operate the lights. So plus 24 volts on the black wire. Let's check each of the colours in turn. Red, green, blue and white. Shall I do that test for you? Let's try it on around about 18 volts from a couple of PP3 batteries. So actually I'll go down to 17.3 volts to allow for a bit of voltage drop. And do they work? Yes, they work fine on that voltage. So you could test them with a couple of PP3 batteries. And I would recommend that you do test all your light strips before you start crawling around under the cabinets to install them. So having soldered wires onto your LED strip like this, you might think, well, I can make them as long as I need to. They can reach all the way around, say, the kitchen or whatever it is, room you're lighting up. I don't recommend that. I mean, sure, you can get long runs of that cable, but it's only thin cable. There's going to be a certain amount of loss on there, and the total currents required are, significant. So don't. Much better to use some thicker cable. This is a 6-way mains rated cable I bought. So when we had the kitchen installed, we had this thick grade cable installed behind the coving, or you could have it run under the floor to reach all the cabinets that are in your room. And then at the end you will terminate this heavy cable to chock block connectors and go from the chock block connectors onto the lighter cable that's on your LED strips. Now, one slight failing of this bright idea is that the colours here are RGBW and the black for common. This is for this particular. Obviously, if you've got an extra white, you'll have an extra cable there, or if you don't have the white at all, that'll be missing. But this 6-way cable here has colours which are more typically used in mains wiring. So we have black and grey and an earth cable and blue and brown. And tell you what the colour matchup I've used is, and why not make it a standard? And that they sort of make some sense. So this stuff is relatively cheap, and you can run good lengths of this with no significant losses, such that the voltage at the end will be anything significantly less than 24 volts. And what I typically do for some of the points is take this to a kind of a junction point and then run multiple LED strips from there. So you don't need necessarily to get an awful lot of the thinner wire, but you'll probably need some. So I'd recommend you get some of this for all the terminations. And the big problem, of course, is that any normal, say, kitchen will have lots of small cabinets that you're installing this into. So the odds are that you're going to finish up with a great deal more connections than were supplied by the manufacturer. And there's something else I need to tell you about that. The supplier I used, who I'm not sure I'd recommend, provide this in this lovely diffuser. It's called a slimline or low profile diffuser. They provide this in 1 meter lengths, and it comes with some clips. So there's some rather nice clips here, and you can screw those into the woodwork, and then these strips clip in. And the way I typically do it, pull this apart slightly because it's a little bit oversprung. You push the strip in one side, let it clip over to the other, and you may need a screwdriver. I managed to do it with my hands there, but typically when you're installing it in a place, you'll find that a little bit hard, and you'll need a screwdriver to pop that over. But that makes a really neat job. So usually you'd only need one each end, but of course they provide as many of these to give you one each end of this, but you're going to end up cutting this down to get around all the awkward spaces, so you need a lot of extra clips. So make sure you order a load of those in advance. The supplier I used charged a great deal of postage, so that ordering some extra ones of these was ridiculously expensive. A fairly obvious thing, I think, when you're cutting this, if you, for example, have a 1 meter and a half meter, so for example, you might have a short piece and a long piece. But what you don't do is just join them like that, with the diffuser and the channel both finishing at the same time. Instead, swap them around, and then the diffuser will sit fully in the channel and will tend to hold it together better. Now let's talk a little bit about driving the LEDs. So the way I have it set up is I have one set of LEDs which are available on the under cabinet lighting, and the other which is the plinth lights or floor lighting. And these are not individually addressable LEDs. Every LED in the strip will light the same colour. So I have the two sets for some colour adjustment there. You can get individually addressable LED systems. Here is a WS2812 type LED strip, and this has less connections. It only has 5 volts ground and data. The data runs along, so this allows for more control because you can address each of the LEDs in turn and have them do patterns of light. That's not what I would recommend for indoor using in the kitchen, because you need, in a system like this, this is several meters, this is 5 meters of lighting. If any controller fails, what will happen is all the LEDs from that point onwards will fail, and they're not that reliable. So let's stick to these systems where every LED on the system operates at the same time. So however many different zones you want, in my case 2, you will have one controller. Then there's the power supply that drives the controller. Now this is a typical power supply. This one is 6.2 amps at 24 volts. So this is sufficient in my case. This will work the lights for under the cabinets, because I only have a few meters of those. For the lights that are operating the plinths, there was a lot there. There was, well, the original order for something like 20 meters. Okay, there's some leftovers at the end, but even so, quite a lot. So the total current consumption was more than this power supply is capable of. And the supplier provided a power supply as part of the kit, but it's a horrible thing. It's just far too noisy because it has a fan, and the fan's not intelligent. It doesn't come on when it's needed, it just comes on. So for domestic use, it's no. That would be fine if you're lighting something like a shop where a small background noise won't matter. But in a domestic environment where you've got a constant whirring of what sounds like a noisy computer, it won't do at all. And the supplier didn't say in their information for that kit that they provide a power supply that's unsuitable for domestic use. I contacted them and they were pretty useless. Eventually they said, well, you can send it back provided it's no more than 3 weeks old, but it had taken them several weeks to decide to even really talk to me properly about the thing. So they basically just left me high and dry. I may modify that power supply to reduce the amount of noise that comes from the fan, because in any normal situation I'm not drawing anything like the maximum current, but it does take more current than the smaller power supply can provide. I could just throw that power supply in a bin and get one of a higher rating that is silent. And one of the other things that supplier had said was, well, you could strap two of these together in parallel. That sounds very dodgy to me, because one or other is bound to output a slightly higher voltage than the other, and you're going to get an effect where one does all the work and is possibly tripping out, and the other is only kicking in when the voltage falls. And actually I did an experiment with two of these, and guess what? It didn't like it. The power supply was making a horrible noise, and one of the power supplies was making a horrible noise. So that's not really a solution. Another thing that should be noted about these, you heard me just go click, is that there's this cover that goes over the connections, and that's fine for DC, but there are also the mains input on here, and that cover does not provide sufficient insulation that you could use one of these in, say, a cupboard which is easily accessible. So you need to make sure that any power supplies are well out the way from prying fingers. Exactly how you mount that will vary a lot between your installation. One possible suggestion could be in the kickboards themselves, or the plinths, but if like me you've got LED strips in there, you might find it a little bit difficult to access those once you've got all the lights in, because you need to do something with the power supply. Now we need more than just the power supply, 24 volt in this case. We need a controller that drives the colours on the LED strips. I have two, one for each of the sets, and in this case they work from these radio frequency wireless remote controls. So these aren't infrared that you have to point at them. The controller can be inside a cupboard somewhere. You can also get them that would work from something like an Amazon Echo, but in our particular case, ours are designed so that when we walk into the room, the ceiling lights and all the 24 volt lights all come on automatically and then time out after a certain amount of time. So that's just what we preferred, so that we don't tend to leave lights on all the time. Now these are quite nice. This remote control can work up to 4 zones, 4 of the controllers. So we have ours set up for the 2 we have. And you can press scene buttons. There's only 2 unfortunately on this particular one. So we can have one scene to do colours and another scene to just do white, for example. And by spinning your finger on this, you can select all kinds of different colours, which is very pretty. But there are some colours you can't achieve just on a remote control. There are ways of solving that. You could add buttons, or in this case I've just got a wire and I can just tap these connections, and I can therefore increase the brightness on each of the 4 colour strips, or switch them on and off. And then once you've got exactly the colour you want on there, you can learn it on one of your scenes by pressing and holding the scene button, and it remembers that the colours you've got them set to are the colours you wanted to store as that scene. There are other functions on here as well, like slowly revolving colours, but it doesn't chase, of course, just they all change at once. These are the two types of power supplies I was originally supplied with. So this one is I'm using for the under cabinet lights. It's 6.2 amps at 24 volts, and this is the one that I've been having so much trouble with because it's way too noisy, and that's 24 volts at 15 amps. But I'm not actually pulling anything like that. I'm pulling probably around about 9 amps peak, so it doesn't need as much cooling as it's got here. So my plan is to see if I can make this a bit quieter, perhaps by putting a resistor in series with the fan. Now, it would be ideal if the manufacturer had included a thermal solution so that as it warms up, it runs the fan more, but unfortunately they didn't, and that's going to be a little bit hard for me to add as a retro thing. And I don't care about the guarantee on this because as far as I'm concerned, if I can't get this quieter, then we'll throw it in the bin anyway. So let's open it up and see what we can do. So I'll power it up. And that's the dreadful noise it makes. Completely unacceptable. Let's see how it comes apart. Because the guarantee sticker's there, it clearly involves that part. The label says, opens and forgive, not to protect, to fix. Not sure what that means. It was built in March 21, so it's not old. But it is, as far as I'm concerned, wholly unsuitable. Okay, that actually came apart pretty easily. You know what, I think there is some sort of thermal detection in here. I think that's a thermistor on the heatsink to these transistors. So it is, I believe, measuring temperature, but it doesn't go as far as to control its fan speed accordingly. The fan is 24 volt, 0.15 amp. There's a 3-pin connector there, but I don't know if it's the inner pin is connected to anything. So there's just metering ohms across the 24 volt feed to the fan, and now looking at the center pin, appears to be completely open circuit. So I don't think that's any option for temperature controlled fan or anything like that. Let's do an experiment using our power supply to see if altering the supply voltage down from 24 volts reduces the speed and noise of this fan. So doing it this way is safer than messing about with the actual power supply. Right, I've just put this resistor on here so I can make good contact. So I have about 24 volts on this power supply. Let's connect that up the right way round and just confirm it makes the most dreadful noise that it does when it's in the main power supply. Okay. Now I'll turn it down to say 20 volts. Oh yes. We're at 17 volts. 15 volts. 12 volts, but would it start reliably on 12 volts? Let's disconnect it and reconnect it. Yes, it does. And it's drawing about 40 milliamps according to the power supply. So I think somewhere in the 12-13 volt area would be adequate. I think there's plenty of cooling from that. There's plenty of airflow. So let's go for around about 12-13 volts. So I'm looking to lose, say, 11 volts at 40 milliamps. Bit of Ohm's law should solve that. Right, what I've settled on here is two 470 ohm resistors in parallel. So we're going from that horrendous racket to that. But there's still plenty of airflow. And I think, this power supply could potentially be mounted in some really hot places and you might need a lot of airflow. But for us, it's going to be mounted in a place where there's plenty of air anyway, and I'm sure that amount of air will be ample to keep the unit from getting too hot. So I'm going to fit these resistors carefully so they can't touch any live electronics inside the power supply. Also have to watch, of course, the wattage, and by choosing these fairly chunky resistors, they're more than capable of taking the amount of heat that they will generate. Okay, it's almost ready to reassemble. So what I have here is the two resistors in series with, they're in parallel and in series with the fan, and a switch to bypass those resistors. We'll have a quick test of my system. I've got this on a 24 volt power supply. That's full speed with the resistors shorted out, and that's reduced speed. So now that should connect up to the original connector on the power supply and hopefully will work. If we look very close, there's a 0 ohm resistor across a terminal point labelled T switch 2. So that must be a thermal switch. There was an option for thermal control of the fan. Right, let's connect up, and we should at least be able to control the speed of this fan now. So we'll start with the switch in the shorted out position, which is shorting out the resistors that I've added. And now we'll switch it to the slowed position. That's perfect. So now I'll mount that switch there, out of the way but accessible. So there we have my modified fast and slow fan switch. Good, I'll go refit this. That modified power supply is nice and quiet. We only have a few small details now to finish off in the kitchen. Now, of course, this video has been well off my normal subject of audio and video technology and Betamax and the likes, which of course I will get back to in due course. The next few weeks, though, I've got something coming up which is electrical and electronic related, but not audio video technology, and I hope you'll join me for that as well, because I think it's really going to be interesting. Please remember to like, share, and especially subscribe, and I'll do a lot more content on audio, video, and other technology in the near future. Bye for now.